Welcome to Airbus Direct at Singapore Airshow for the last time. We're here in the Airbus comfort zone. What a week and what a show. The A350 XWB test aircraft has been wowing the crowds with its elegant, extra quiet flying display. In the early afternoon, the A350 XWB took to the skies above Singapore for its flight back to Toulouse to continue its intensive flight test campaign. This will be its longest flight so far, some 13.5 hours non-stop. Bon vol! We wish our A350 crew a good flight home. Now let's discover what the cabin interior of the world's most modern aircraft will look like. Today it's all about cabin comfort, and in particular for long haul. So we'll take a look at why comfort is so important and what Airbus is doing to ensure that comfort is without compromise. We're here in the Airbus Comfort Zone at the Singapore Airshow 2014. I'd like to welcome Christophe.
Welcome, Marcella, in the Airbus Comfort Zone. So,
Christophe, how would you define cabin comfort?
Cabin comfort is based on several factors, which are quantitative and qualitative also. You have factors or a contributor to comfort which are physical, like the anthropometric or the ergonomic of the seat. But you also have factors which are very linked to the mood. For example, here you can see the mood lighting in this mock-up.
Thank you, Christophe. And also, could you tell us what are the key drivers when you're designing a comfortable aircraft cabin?
Yeah. Obviously, what is very important for the passenger is the perception of well-being when they board the aircraft. So what we try to do is open the space as much as we can in the cabin, as proven in this open cabin with a pivoting bin of the A350. But something very important also is to offer wider seats which are comfortable for the passenger.
And also, Christophe, could you tell us 1 more inch for the seat width? Does it really matter?
Yes, we used to say every inch counts. Why? Because if you are flying long-haul flight, you will spend a lot of time in your seat. Let's take the example of MSN3, which is coming back from Singapore to Toulouse. It's 13.5 hours. And if you are sitting in a seat 13.5 hours, you have to have the comfort to move within your seat. So each inch is very important for that. And we know with all our surveys that it's very important also for the notion of privacy. You have the natural separation between rows, which is given the back shell, by the seat back shell, but the width of the seat really helps to get you a sense of privacy.
So as we're here in Asia, we'd like to share with you some fresh research that explains to us just exactly what matters most to Asian passengers in the cabin.
The report has done is to encapsulate the thinking of 8,000 consumers, affluent consumers, starting out on the kind of lifelong travel journey, and it really has just captured what their needs, their requirements, and potentially their future thoughts will be about airline travel over the next decade. 60% of the passengers believe that a wider seat was one of the things that contributed to overall sense of comfort. Over 42% of them said they would pay more if the seat was bigger, and I think it was something like 53% were actually saying that in terms of improved productivity, the width of the seat and the additional legroom made all of the difference. So really what you were seeing were very clear figures pointing to one clear thing. The bigger the room in the seat, the greater the width, the greater the sense of comfort among those passengers.
I'd like to welcome Tora. Hi, Tora. So we've just looked at that new research. Could you take us through what are the main findings and what have we learnt?
There are actually 2 main findings. For Asian passengers, sleep means productivity. So for them, it's very important to relax on board the aircraft, to really recover from the hard working day. And as 70% of Asian passengers fly for business, you can imagine that really most of the people in the economy class really would like to sleep. Yeah? And sleep for them means productivity. And as our recent sleep study has found out, you can sleep 50% better in an 18-inch seat versus a 17-inch seat. Yeah? And All our aircraft have 18-inch as standard.
Thank you, Tora. What we'd like to do now is look at some of the main innovations in Airbus cabins and what makes Airbus cabins the most comfortable in the world.
Airbus cabin development and innovation is driven by the single strategy, passenger at heart, airline in mind. What does it mean? Our target is to develop and improve the cabin in order to provide a comfortable passenger cabin, passenger experience, and enhance passenger well-being. But on the other hand, offer a product to an airline which is adaptable to market changes and improve the profitability of an airline customer. Passenger comfort is not only the seat comfort, but as well as overall environment, which means the air, quality of air, the temperature, and the lighting. So we have worked on those three elements in order to improve passenger experience. On A350, we have located flight and cabin crew rest facilities in the ground area and out of passenger zone, which means the airline can very efficiently use space in the cabin, full length of the cabin, to install seats and optimize their revenue potential. In the same time, these facilities offer great rest for cabin crew, and rested cabin crew can deliver better service to passengers, which is part of passenger experience.
Mike's now going to explain to us what makes the A350 cabin so appealing both to passengers and to airlines. Mike.
Well, Marcella, what really counts for airlines is very much trying to get as maximum reduce costs down to a maximum. The way they do that is by getting more seats into the aircraft. What really counts for passengers, of course, is comfort. With the A350 XWB design, we've actually managed to balance both comfort on the one hand and efficiency on the other. It's wider than our previous programs, and therefore we can actually get an extra seat in per row, so we're bringing the cost of seats down. And of course, we're keeping our 18-inch comfort in economy, which means that we're keeping the same level of comfort, so providing the optimum balance between both comfort and economics.
Thank you, Mike. Could we try and bring that to life a little bit? And could you take us on a virtual tour of the A350 cabin?
I'd be delighted to. So you can see here, going through in through the aircraft through door 2, wonderful welcome area with this superb dome, and we're turning left now, going into the business class section. With the extra width of the A350, we can actually accommodate any of the new innovative business style seats. Here we have one of the newer seats, and you can see moving back towards the cabin, mood lighting that can flow all the way down the cabin, underlining the smooth flowing lines of the cabin. Of course, comfort is not only for passengers, it's also about crews. When you're on long-range missions, you need to be able to provide comfortable sleeping quarters for the second set of crews, and these include even IFE. Coming out, of course, the crew could have a dedicated lavatory, and why not? We're moving to the economy class section with our 18-inch seat. This will be the first aircraft to actually be able to offer full high-definition widescreen TV. Moving back again, we then go into the cabin crew rest facility, up to 8 bunks here to sleep the cabin crew in ultimate comfort, and you can see they open out nicely onto the galley. Walking back through our lovely economy class section is where we all feel like we really want to take a seat now and enjoy the IFE and connectivity, which will provide us ultimate comfort.
Thanks, Mike, and thanks to all our special guests, and thanks to all of you for watching us. So the show's nearly over, and it's time to wave goodbye to the A350 test aircraft as it's heading back to Toulouse on what will be its longest ever flight so far, some 13.5 hours. And these hours will add up to the already 1,000 flight test hours that the program has achieved so far. But before I leave you, I'd like to take you, thanks to Emanuele, on a very special tour inside our test aircraft.
Welcome on board of A350 MSN3. This is the second prototype that is currently flying and on which we have a heavy flight test installation. This aircraft is going to be dedicated to system test, engine, APU, braking, air conditioning and so on, performances, low speed, high speed, and to other tests which require effectively a heavy installation. That's why the interior of the cabin is quite different with respect to an aircraft which is going to operate in an airline. It's a naked aircraft. It has its charm because sure there is no cabin, but at least you can see how the structure of the aircraft is and what is behind the fairings of the cabin. All the cables that you are able to see here and which are orange colored or which have an orange support are specific to this aircraft, to this prototype aircraft. They are orange is the color of flight test and this means that all the items that you can see in orange inside the cabin, inside this cabin are required to support the wires, either electrical or pneumatic, which are necessary to the functioning of the flight test installation. There are specific devices which are also installed inside the cabin and that are taking a certain volume. For example, these devices that you can see here are called load benches. Since we have no galleys in the cabin, there are no ovens, there is no in-flight entertainment, we are not able to load completely the generator of the engines or of the APU. But for flight test purposes, we need to load them to the maximum and even above the maximum. That's why we have to simulate these electrical loads by these devices, which are simple resistors that we are going to activate from the flight test engineer station and which are going to increase the load on each engine generator or on the APU generator up to the maximum and above the maximum. They are quite cool for the time being, but as soon as we activate them, consider that each engine generator has a 100 kVA electrical load. The cabin temperature is going to increase, so we have to manage all of these in order not to exceed the maximum temperature inside the cabin. These other monuments that you are able to see here are devices that are going to support the flight test engineer station. There are electrical components, there are pneumatic components, there are converter, and so on. And all of these is going to support the recording of the parameters that we have on board. We have more or less 600,000 parameters which are recorded. So from the different computers in the aircraft or from the specific probes that we have installed, temperatures, accelerometers, pressure probes, strain gauges and so on. And all these data are recorded in a specific hard disk and most of them can be live monitored from this station. This is where I work. This is the flight test engineer station. From here we have the possibility to display the various systems which are belonging to the aircraft. And also there are some pages, specific pages that have been prepared by the flight test engineer all together with the engineers that are on ground that allows us to facilitate the monitoring of the system's behavior during a specific flight test. So we can monitor the parameters. Just to give you an idea, you can see, for example, what is the information of the flight controls on the pages displayed to the pilots and on the page displayed to the flight test engineer. We have the possibility to plot parameters, as you can see on the lower screen, which allows us to see versus the time the behavior functioning on the various systems that we are testing. And we have the same information as the pilots in the front in order to be able to understand if they see something wrong, some anomaly, and to be, let's say, on the same understanding, on the same frequency. And afterwards we have also cameras with which we can monitor the different parts of the aircraft. We can add other cameras depending on the flight test that we have to perform in order to have a look at what we are testing. For example, for the stall test, where we put specific devices on the wing in order to characterize the aerodynamic flow. We have cameras that are installed on each side of the fuselage and that we are able to monitor live and that are going to be recorded also for post-flight data retrieval. From this station, we have also the possibility to communicate with the various computers of the aircraft. And we have the possibility to change some of the laws that are inside these computers. For example, we can decide to change the flight control laws. We can increase the gains of some schedules and to make an aircraft be more responsive or lazier or more suitable to what the pilots identifies during the flight. It's not only the flight control computers that we can control, but there are also the computers of the braking, of the air conditioning, of the ventilation, and so on. We cannot intervene directly on the engines. That's why there is a specific station that is to Rolls-Royce, and where a Rolls-Royce engineer sits, and from where he is capable to monitor the various parameters, more parameters than what we can do, and he has the ability to intervene on the EEC in order, which are the computers installed on the engines, in order to change, as we can do from our station, in order to change in flight the laws, the schedules of the engine. For example, if we have to perform some transient test, some thrust response test, and we find that the engine acceleration is not suitable to our targets, we have the possibility, after validation done on the bench, to apply some trims, we call them trims, in order to boost the engine response. And this is a quite efficient tool, both for the engine and for the other systems of the aircraft that we can control from our station, in order to increase, to maximize the efficiency of the flight test. Because you can understand that in the frame of the same flight, we can test different schedules, we can test different adjustments, and so in back-to-back have a live feedback on the acceptability of the tuning that afterwards will be inserted hard inside the software. All the other monuments that you can see here are specific to the flight test instrumentation. There are the recorders somewhere, there are the circuit breaker, the electrical supply, all these big stations that you have seen in the back. We have here some compressors which are going to blow the pipes, the pneumatic pipes that are linked to the pressure probes that we have more or less everywhere in the aircraft, in the engines and or the aerodynamic surfaces of the plane. For example, on the upper surface of the wing or of the horizontal tailplane. And we need this compressor to blow this measurement in order to avoid that they get contaminated or they get iced as soon as we cross some clouds or we are operating in sandy conditions. Here you can see the load benches, the same that you have seen in the front. And you can see also some seats that please don't consider at all as a representative of the much more comfortable seats that we are going to have on A350. They are just basic economic seats, even old style, that are installed here for our specialists as soon as we come abroad for external missions.